Hello, geometry students. We're here in section 13-3. We have some new vocabulary, and the new vocabulary is geometric probability. Okay, so we have the length probability ratio. So what we have here is landing on a random point on a line segment, it looks like A to D, and we're trying to figure out what's the likelihood that we land on the portion of it from B to C. Well, all we have to do is measure the length B to C and then measure or know the measure of A to D and then divide. AD goes on the bottom and BC on top, and that gives you a ratio, and that ratio is the probability. So let's look at the first example. Point Z is chosen at random on a D. Find the probability that Z is on a B. Well, since it's at random on A to D, right, and AD is a measurement of 2 plus 2 plus 7, right, or that ends up being 11 units, and the AB portion of that is 2. So how about 2 11ths? Okay, and we can also change that to a decimal. So here we go. We have our AB over AD. We end up with our 2 11ths, which is about approximately 0.18 or 18%. Okay, check your progress. Go ahead and pause the video and find the probability that R is on line segment portion MN. Okay, you said 13 out of 30, that's correct. So the M part to N is 13 of the total, and the total is 13 plus 17 more, which gives you 30. So how about 13 30ths? Okay, so the next example, it's a real world example. Halley's Comet orbits the Earth every 76 years. What's the probability that Halley's Comet will complete an orbit within the next decade? Okay. So, in this problem, we can use a number line to model the situation. So we have a decade only being 10, right, of the every 76 years. So we can find the probability of the event, just like before, by division. Okay? We're going to do this by taking the EF over the EG, or 10 over 76. Reduces that down to 5 over 38, or approximately 0.13 or 13%. That's pretty easy. Okay, here's one for you to try. Go ahead and pause your video and find out what's the probability that you will get picked up in the next 12 minutes. 3/4. Now how do we get 3/4? Well, we got 3/4 by, oops, I lost my pen. There it is. Waiting for the next subcar, you're unsure how long the last one left. You do know that the subway comes every 16 minutes. So every 16 minutes, what's probably that you'll get picked up in the next 12? How about 12 of the 16? Divide top and bottom by 4, and you get 3 on top and 4 on the bottom. And that's how we get 3/4. Okay, so here's the next key concept, and it's about area probability ratio. So if a region A contains region B, okay, then the probability of choosing, let's say, a certain like random point that we know is in A but falls in B would be the area of the circle divided by the area of the rectangle. So this can work for anything. You could have a rectangle inside a rectangle. So that'd be the area of the small rectangle on top divided by the area of the large rectangle, and so on. Or you could have, excuse me, you could have a circle with a rectangle in it. Or you could have a circle with a circle in it. So we're going to take the area of small region divided by the area of the big region. Okay, so here is an example. Oh, we have three concentric circles, okay, and we're going to figure out the probability of landing in the center circle, given that we randomly will hit somewhere inside the large circle. Okay, so we know that the inner circle has a diameter of 4, which gives me a radius of 2. And then they're spread out 3 inches apart, so we have a radius of 5 and then a radius of 8. So the large circle has a radius of 8. So that's going to be pi r squared, or 64 pi, for the large circle. And the small circle we're trying to hit would be pi times 2 squared, or 4 pi. Looks like the pi's are going to cancel, and the 4's and the 64, I believe, reduce into 1 over 16. All right, let's see what they say. So there's the 8 inches. There's our 2 squared and our 8 squared. Very good. We get 1/16, which then is about 0.06 or 6%. All right. So here's a problem for you to try. Go ahead and pause your video and find the probability if the ring is thrown at random and it lands somewhere in the rectangle A, that you'll land in the B, which means you're going to win a prize. Pause your video. All right, it says about 31%. So let's figure this out. How'd they get that? If at a carnival you toss a ring and it lands in the red circle shown below, then you win a prize. The diameter of the circle is 4. So that means that the diameter is 4. That means the radius is 2. So we're going to have pi r squared for my numerator, or 4 pi. Now that's going to be divided by the total area of A. And it tells me that the dimensions of the blue table are 8 feet by 5 feet. That means we're going to have 40 on the bottom. So my 4 and my 40 reduce, and that gives me a 10. And my answer then ends up being pi divided by 10. Now remember, pi is 3.14. And when you divide a number by 10, decimal number, you can move back the decimal point 1 spot. So it becomes here. So 0.314. Or just about 31%. Okay, next problem. We're using angle measures to find geometric probability. All right, it says use the spinner to find the probability a pointer lands in section 3. Well, section 3 is 122 degrees. Okay, assuming it's landing randomly, the entire circle, the circle is 360 degrees. So how about 122 divided by 360? Okay, so the angle measure is 122, right? And so divide that by 360, because that's the whole circle, and it ends up being about 34%. All right. Angle measure, find it. Says use the spinner to find probability of landing in section 1. Well, I think this is exactly the same. We have 26% out of 360, and that ends up being about 7%. Okay, check your progress. Go ahead and pause your video and find the probability of landing on section C. So 62%, right, or 62 degrees divided by 360. We will double check that. 62 divided by 360. That ends up being 0.1722, or about 17%. Okay, one more. Check your progress. What's the probability of landing on section E? Go ahead and pause your video. Good, you have 96 degrees, right? 96 degrees divided by the 360, and 96 divided by 360 ends up being 0.266, or about 27%.